So in the last session, we have seen about classful and classless subnetting examples, right? And I have given 2 files for the practice questions as well. Did you guys practice? All the questions were easy, right? You got the answer to all the questions? Okay. So no one has a doubt in any of the questions, right?
In submitting, we find the broadcast address and
See, in case of subnetting, mostly you will be asked for either subnet ID, that means your network ID, either the broadcast address or some of the valid IPs. These kind of questions will be there. Then the questions can be there where you will be given a slash notation or CIDR value and you will be asked for dotted decimal notation. Okay, or else you will be given dotted decimal notation and you will be asked for subnet. Sometimes you can be asked for number of networks.
Yes, sir.
So how do we calculate number of networks? Number of borrowed bits. That will give you the number of network. Means when you go with the 2 raised to power number of borrowed bits, so that will give you the number of networks required. Is that clear?
Sir, if someone asks me to divide the network into 3 parts, how can I?
Into 3 networks, you mean?
Yes.
Okay. See, for example, this is your IP address. 0.0, let's say this is the network. By default, it will be /16. Correct? Okay. So when I have /16, how many networks it is? 1 network. Right? This is 1 network. Now you want me to divide it into 3. So in the odd numbers, it will not be divided. Either 2, either 4, like this, it will be divided. Okay. So let's say right now it is /16. When I will divide it into /17, when I'll make it /17, it will become how many bits you will borrow? 1. So 2 raised to power 1 will be 2. So this will become how many networks? 2 networks. Borrow 1 more bit. What will happen? 4 networks. So like this, you have to perform. So if you want to divide it into 4 networks, that means you have to use 18. Okay, that will depend on what is the subnet mask. If it is 24, then you must know that, okay, if I will borrow 2 bits, that means 4 networks. If I will borrow 3 bits, that means 8 networks. Okay, if I will borrow 4 bits, that means 16 networks. So that will depend on 2 raised to power. Okay, number of borrowed bits. Okay, this is clear.
Yes.
And today we have the test also, right? Okay. So next we have one small concept from the subnetting itself, FLSM and VLSM. FLSM and VLSM. So what does it mean with the FLSM? FLSM stands for fixed line subnet mask. Okay, means you will be dividing the networks into equal parts. This is what we are doing, right? Whatever we have done right now, this is what FLSM approach. When all the networks are of equal size, all the subnet masks are same. Okay. Now see, with examples we'll see. This is one small easy concept. For example, consider this is the FLSM approach and you work in a company and the company has these 3 departments: IT, HR, and sales. These are the 3 departments available in the company. And the number of PCs in each and every department, they are like, okay, IT department has 120, your HR department is having 60, and sales department is having 20. Now you have to design network. Okay. Now, if you go with the classful networks, what will happen? Which slash will be the perfect slash according to classful? /24, right? Why? Because we will get how many hosts? 256, right? In case of classful, we have only 3 options: /16, /8, and 24. In case of /8, you will get 1,67,77,216. In case of /16, you will get 65,536. Correct? So if you want to waste least number of addresses, in case of classful, we have the choice for /24, right? So if I go with the /24, you can see I will get 256 addresses for each and every department, because I want that these 3 departments should be in different network and they should not communicate, right? So I will get 256. And when I'm using 256, how many IPs I will actually use? 120. So what will be the wastage here in case of classful? 136. Correct. Here, what will be the wastage? 190. 196. Is it correct? Okay. What about here? 128 or 228? Right? This will be the wastage. When from the total number of addresses, we will subtract how many IPs we will use. So what will be the total wastage in case of classful? What will be the total wastage? Count 6 plus 6, 12, 8, 20. Then 12 to 14 to 16. Then 4 to 6. These many addresses you will be wasting. Okay. Then we know that, okay, we can perform subnetting and we can reduce the wastage. Now, when we are doing the subnetting, we have two approaches. Either we can use same slash value for all the networks. Why? This is an easy configuration for an admin. Admin doesn't have to remember different subnet mask for each and every department. Okay, we will decide one subnet mask, and in entire company, in all the departments, we will use the same subnet mask. Okay. So what will happen? We have 120, 60, and 120. Now, in case of FLSM approach, you will check the highest requirement. Where is the highest requirement? IT department. And what is the highest requirement? 120. Now, according to 120, if I check the slash value, slash 24, I'm getting 256. Slash 25, I'll get 128. Slash 26, I'll get 64. Then 32, 16, 8, 4, 2, 1. Like, so in which of the slash I can accommodate 120 addresses with least wastage? If I go here, wastage will be more. If I go here, wastage will be less. Okay. Here wastage will be 8. Here it will be 136. So I will go with the slash 25. Now I have decided the slash value for the highest requirement. Now the same slash value I will use for all the departments. That is what your FLSM approach is. Okay. That you will use the same slash value everywhere. Why? Easy to remember. Second option, let's say at some point of time, in case of sales department, you will need more PCs. Okay, so you can easily, you already have 128 addresses, so you can accommodate more number of PCs here. Means we have a scalability option here. Okay, so advantage is you get the scalability option. You can increase the number of PCs without changing the network. Without changing the subnet size, you have the option to increase the size of network. But disadvantage will be if your number of PCs is less, what will happen? Again, wastage will be higher. Again, wastage will be higher. So if you get 128 addresses in each and every subnet, right? So out of 128, you are going to use 120. Wastage is out of 128, you will use 60. Wastage is out of 128, you will use 28. Wastage will be. So what will be the total wastage? 176 addresses. Correct. But what is the advantage? You get the scalability option. You can increase in future, you can increase the number of pieces. Is that clear? Okay. Now let's say if I want to write the IP range according to this, and if I choose any network, let's say class C network. So how I will use for the IT department, my first range for the IT department will be, let's say 192.168.0.0 till how many addresses I will get in slash 25? 128. So for starting from 0, 127. 0.127. Then next range will be 128 till 255. Okay. Now what about the next range?
1.0.
1.0. Correct. Because your fourth octet is already maximum. So this will become 1.0. And it will go until 128. So here, how many networks I'll be using? If you see 0.0 completely used and 1.0 half used. Correct. So means still I will need to buy 2 networks. I'll need to use 2 networks. Is that clear? And for each and every network, what is the size of addresses? 128. Correct? And if 128 means the subnet mask for each and every department is same. This is why it is known as fixed length subnet mask. That one subnet mask for all the networks. Is that clear? Now, if you want to further reduce the wastage, then we will perform the subnetting based on the department level. Different subnet mask for each and every department. So one way is we can choose the same subnet size for all the networks. Okay. And the second approach is variable length subnet mask. Variable length means we'll keep on changing. Okay, not fixed. So here we have the same example. Okay, again, if we go /24 is going to give you how many addresses? 256 /25 will give you 128 /26 will give you 64 /27 will give you 32 /28 will give you 16 /29 will give you 8 /30 will give you 4. 31 and 32 we cannot use. Okay. All right. Now we have the requirement 120, 60 and 28. According to 120, this is the good one with least wastage. According to 60, according to 28. Correct? Okay. So we will use the different subnet mask for each and every department. Now if we see these many addresses we will get. And according to this, out of 128, you will get 120, wastage will be 8. Out of 64, you will use 60, wastage will be 4. Out of 32, you will use 28, wastage will be 4. Correct? So total wastage 60. From 176 addresses, we bring down the wastage to 16 addresses. This is why VLSM approach is better. Okay. Now about the scalability option. So here you do not get much of the scalability. Okay. That will completely depend on size of the, like how many hosts you are having and how many free IPs according to your subnet mask you are having. Okay. Now at a later point of time, let's say this is 28. Now it becomes 33. Okay. Tell me one thing. What if the requirement is 32? 64? What if the requirement is 31?
64.
Why?
Last and last IP.
Correct. Always remember that in any network, when we are giving this block size, your valid IPs will always be -2. Why? Because the first IP and the last IP reserved for network ID and broadcast address. So this is the total block size. Ultimately, we will get only 30 IPs. So up till 30 IPs, we can use the same slash. As soon as it becomes 31, we cannot use it. Okay, we have to go with the /26. Is that clear? Now here, if I have to write the IP range, tell me the IP range. Okay. Because in this case, I'll get 128, 64 and 32. And if I want to use the same network, so my first range for the IT department will be 0.0 till 127. Okay. Second range will be 0 to 63. How? You already use the same IPs. 191. And the third range will be 192 till
223.
This is clear to everyone? Or there is doubt? Whatever IPs we have, according to that we have written. So you see, still we are using the 0 dot network and we still have the IPs left from 224 till 25. These many IPs we already saved from one network itself. Okay, so this is why if you want to add in one more department at a later point of time, you can easily use the same network and provide the connectivity if the number of IPs required is less. If the number of IPs required is less. Okay, is that clear? Okay. So FLSM, VLSM clear for each, and in case of FLSM, subnet mask will for all the departments will be same. In case of VLSM, it will not be same. On department level, it will vary. Okay. All right.